Hi everyone. So today I will explain how I decrease this LCP. So on the slide you can see that there is 350 milliseconds. The number is is actually a bit lower, but I didn't want to put the real number here because you may think it's unrealistic. So first, I will give you some intro and show you how it works at the demonstration. Then we will think about how it works internally. Then there will be basic implementation instructions, which is most important part. Later, I will show you how full implementation, what you need to know about fully implementing it, and the main benefits lies there. Besides, I don't have PhD in debuggerology. I will show you ways to debug it and also to test it. And there will be this part regarding measurement of the impact. So first, LCP, largest contentful paint, is one of core web vitals, which tells you how performant is your page. It is largest element on the website. If you can see the conference website, the largest contentful paint element is marked visibly. So now when you know what LCP is, let's think about why to optimize it. And there are two main benefits. First one is that Google encourages webmasters to lower the LCP by giving them higher positions in Google. So if your LCP is below 2.5 seconds, then you are higher in SERPs. And probably lowering it more does not have much SEO impact. But there is also conversion rate impact. And there are multiple studies that show that the lower LCP, the higher conversion rate, and it goes to zero. It's best to have zero LCP. So something about to give you context, I am a founder, co-owner, and CTO of Planujemy Wesele, which is a wedding vendors directory. It allows you to find a photographer for your wedding, music band, etc. So we are a Rails application. We started 16 years ago. And some time ago, we introduced Next.js as a front-end part of the application. We are still migrating our front-end. And a very important aspect of our website is that most of the traffic comes from Google. So now let's go to the demo part. So it's just a movie. Is it working with this microphone? Okay, so we can see that this is just a movie. And the first thing I do is clear browsing data so that we can ensure that the cache is empty. Next thing is typing some search phrase in Google. You see the results. You can see my website is at the second position. Next, I am throttling the traffic to slow 3G to simulate slow connection. And then I click it, and you can see that the page shows immediately, and the LCP, you can see it's 140 milliseconds. So this is how it looks like. So you can ask how I achieved that. So did I use Pied Piper compression to quickly send this amount of data? I can tell you that I just use good old prefetching, so that the website is being prefetched at Google search results, right? If you don't remember how prefetching works, it's just a single HTML tag where you specify URL, and when browser sees this tag, it prefetches the link. When user travels there, it is fetched from the cache, not from the network. So now we will have reverse engineering session. So we will try to find out how it works on a living example. Yeah, so can you hear me? Yeah. Let's start with Google search. So first, let's open developer tools. And we can see there is a network tab too, and we will see all the network requests that are made by this page. Now I'm entering the search phrase, which means music bands, wedding music bands in Rzeszów city. And let's execute this query. Oh, there's some captcha. It's probably I'm using VPN, so I haven't expected that. There will be more probably. Yeah.
You can do it.
Yeah. Yeah, there are still more. Oh, this is not a motorcycle. Oh. Yeah. I think one more and we'll be ready to go. Yeah. I don't know why it does not work still. Okay. There is slow connection. So now you can see, oh, there was some error here. Maybe I'll refresh the page. Yeah, that's probably because of the slow connection. One more time. No, it's there is no throttling here, right? Yeah, so something is wrong, and I bet it's for connection, but it's actually not very needed. I will refresh once again. Okay, and you can see here, if you scroll the connection, the one in red, which resulted in error. Yeah, there is this turtle here. So it was so slow. It was probably cancelled because the response time was slow. I don't know why, but you can see that it is being prefetched, right? So now let's go to the yeah, because you can see that it is on the first place. Now we should examine the HTML of the page to see how's this magic thing work. Yeah, so you can see here clearly, right? There is this link prefetch, and yeah, that's it. I can hear some smiles, hear some laughing, and see some smiles. Maybe that's because you notice that. I'm sorry, I should close those pages. Okay, so I think now it's better. So Yeah. Those of you who haven't loved, I should explain that this is not real, but why it's not real? Why Larry haven't decided to use this approach? Do you think? Do you know why? Why the page is not being prefetched in such a way, such a simple, naive way on Google search results? Do you have any idea? Okay, so maybe I will try to add some hints. So the first one is privacy, because you can see that when the request to my website is being done from Google search, I can see entire requests at my infrastructure. I can see the IP of the user searching at Google. He may not decide to visit my page, right? But I can see it. And I consider Google search as a confession. You want it to be secret, right? Every request contains a referrer, which can contain a query string, but actually it is already solved. Google does not send a referrer. So yeah, the first thing is privacy, most important. And the second one is that Google has no control over what is being prefetched. You can prefetch something for this particular user, which you identify by IP. You can, for example, send 10 megabytes to some mobile user to saturate his traffic. So probably Google don't want those things to happen and they don't even see that it's happening because it's between user and my server, right? So that's maybe it was one of the reasons in 2015 accelerated mobile pages, AMP in short, were introduced. So the basic idea is to keep the simplified version of a page on Google servers and prefetch it from there, from Google search results. So they invented entire HTML framework for creating these simplified pages. And this solution offers much better privacy because there is no referrer, there is no IP passing, etc. to original server. Everything is served from Google infrastructure. There is more control because all the content is cached at Google servers, so the website owner can't do any malicious things. And of course, the framework is very lightweight. The pages load super fast. And there are also downsides. The framework is very limited. You don't have full power of HTML and all the technologies. It is mobile only. And it has these ugly looking URLs. The URL starts at Google because it's served from Google Infra. And you may think, what would happen if Google goes rogue, Google becomes evil? They may modify those pages, right? For example, for particular users. So we need to trust Google 100% on that. So maybe we can fix it somehow today. So I would suggest first ditching this entire lightweight framework. Let's unlock developers and allow them to use full power of HTML. Then let's cryptographically sign the page and keep it on Google servers like before, so that the webmaster will be happy that the website is not altered. And the rest is the same. Let's prefetch this cached version of page from Google, and let's modify our browsers to check the signature. And if the signature is valid, we can display original URL in URL bar. So what the name should be? How should we name this technology? There are a lot of data flows from server to Google and from Google to browser. So every request response is an exchange of data, and a lot of exchanges need to happen. And cryptographic signing is involved. So what about signed exchanges? And actually in 2018, signed exchanges were born. It's called SXG in short. It is at the current level of standardization is its draft standard. However, draft standards is almost totally complete. It's very near to a real standard. The fun fact is that if you type in Google signed exchanges Wikipedia, you won't see any results for that. It's not very known. However, it has quite good support because all Chrome-based browsers support it. And Cloudflare has support for that. There is an Nginx module, and recently I learned that if you use Fastly CDN, you can use it also, but it requires some manual work. So this is how it works. So first, Googlebot tries to index your page and performs a request to website, but it specified its accept header to signed exchange. So this is a signal to website to return SXG package. I call it package because it's this HTTP response is packed and signed. So now Googlebot could put that package to Google Cache. This is critical component, and it cost me a lot of problems. It is opaque, it is underdocumented. So now when it is in cache, the browser could, the user could search for this query, get some results, and the prefetching happened from the Google cache. The browser puts it in a prefetch cache, and later when user decides to click the link, he thinks that he visits the website, but the website won't even see his request because the request goes to the prefetch cache and SXG package is being returned, right? So you can think of it as a method of offloading traffic from your website. So how Google decides which pages to prefetch? They use this your current position. So they use the position you have in Google search results. So from my experience, about 3 or 5 first results are prefetched. It's quite logical because prefetching everything would be a waste of users' bandwidth. The first 3 or 5 results are much more likely to be clicked. So how to enable SXG? It's very simple. If you are Cloudflare customer, Cloudflare has very nice packages, subscriptions. I think I paid $20 or something. It's not costly. So it is one click of a button, right? You can enable it, and Cloudflare acts as a reverse proxy to your website and creates those SXG packages. And at this time, I could tell that it's all. However, Steven already did that trick, so I can't use it. So there is more. So apart from clicking this button, you have to rewire your brain because you have to think about you have to distinguish between content creation, generation, and content distribution. Those are two separate things. So in other words, you can we should decouple request from the response. because the same response could be reused for many requests because it's cached. So the response begins life of its own. And there are some constraints your response has to meet to be SXG friendly. And most important thing is that SXG friendly means it should be cache friendly. So we should set this cache control header with max age set to some value and public because cache is public. The value of max age should be between 120 seconds and 7 days. If you set it lower, the SXG won't be generated by Cloudflare. If you set it higher, it will be capped to 7 days. So I did a lot of thinking about which value should I choose for my website. And I came up with these 24 hours. So pages are cached for 24 hours. And it works better than as expected, because I was expecting that if someone visits the page, other person should wait 24 hours to see fresh version. But Googlebot visits most of the pages more frequently, and it updates the cache. So this is how it's done in Rails. In Next.js, there is no way to override cache control header because it's used for internal Next.js things. So we need to have a hack. We create some other header and later rename it at web server, for example. Yeah, what are the other response requirements? The most important is you can't do server-side personalization, and it may be a big pain for Rails developers because Rails is based on server-side personalization. So if you, for example, return different response based on user agent, language, country or IP, you should forget about that and do it differently, because there are ways to do that. And you can't have cookies. Maybe some of you know I'm keto follower, so I should encourage you to go keto and forget about cookies. But actually, as in keto, there is also keto cheating. There are cheat days. So the requirement is related only to server-side cookies. If you are on front end, on the cookie, the client side cookies are allowed. Right? So you can have Google Analytics, for example, cookie banner cookie. So the first most important cookie in Rails is session cookie. The way I resolved the issue is I created a special endpoint just for fetching session cookie. So my website is static, but it contains JavaScript which fetches this cookie from this endpoint and uses it in later requests. And other cookies, I had to grab code for cookie string and replaced it with client-side solutions or remove it entirely if it is not used. Currently logged user. So there is this pattern that currently logged users in the upper right corner of the screen. There is this avatar, image, and username, right? It should also be moved to client side. We can create some endpoint returning current avatar URL and name, and it should be hit by frontend. Yeah, and there is also CSRF, which is a security mechanism in Rails. It prevents SXG from being generated because it generates unique content on each page rendered for each user, for each session, probably for each page view the result is different. So one way is to disable this mechanism, but I don't recommend it because it's very important. The other way is to move it also to client side. It can be done. I show it how to do that on the blog. And there is a HTTP strict transport security mechanism, which also prevents SXG pages to be generated. The fix is quite easy because you just need to remove one header. If you do this at, for example, Nginx, you can also reconfigure Rails to not include this HSTS header. And if you use Cloudflare, it contains the switch to enable it at the Cloudflare site in a way compatible with SXG. Yeah, I also did first impression optimization. It's not strictly related to SXG, but it contributes to faster page loading. So the website assumes that user is visiting it for the first time. So, for example, user assumes that user is not logged in. So this way, the API endpoint for checking if user for returning username and avatar is not being hit. It may seem as a very small optimization because we save one request, right? But it's not only for humans; it's only for bots. If there is a SEO concept called crawl budget. So each crawler has some amount of request, some limit of request to perform on your website. And if the limit is reached, it stops indexing your page for a given day, for example, right? So shaving one request makes the bot index more pages, which is beneficial. And you can see it here. Yeah, this is a place where I introduced this and other optimizations. You can see that average response dropped, right? And the number of indexed crawled pages increased. So all those things I said up until now are related to optimizing HTML response and HTTP headers of the main document containing your page. And if you think of the amount of work you need to put to make it work up to until now, it's quite achievement, and you gain very small results because only the HTML will be prefetched. HTML is quite small and the gain is very low. But then when you prefetch also so-called sub-resources, so CSS, which is critical for displaying the page, until the CSS is loaded, the page is white, right? There are also images to prefetch, which directly affects LCP, fonts, and JavaScript to make the page interactive. And the curve looks different because it's just few simple things if you know how to do that. For me, it looked differently because there was a lot of debug I needed to do. So, how to prefetch sub-resources? We use link HTTP header for that. This link is used also for a mechanism called early hints, which is advanced optimization technique used in some servers. Cloudflare supports it. I like it. But for SXG, we need to use different format for this link. So each sub-resource should be hashed, and the hash should be included in this link header. For each URL prefetched for a given main document, we have to have the hash of given sub-resource. So it needs to be generated. So it may be not very simple to do if you have terabytes of assets stored in S3, for example. You will have to download it, hash it, save it to database, etc. Right? But Cloudflare automated signed exchanges called ASX can do it for you, right? They just download those things at each request, hash it, and include it link header. Yeah, so this is what it does. It parses the HTML of response, finds all link rel preload links inside your head or body, generates hash for each sub-resource, and adds it to link header. And the problem is that Rails already has optimization, is optimized for early hints. It generates its own link headers if you use helpers for sub-resources, for some sub-resources, such as stylish link tag or JavaScript, etc. And there is no way to remove this functionality. It is buried very deeply in implementation. So the Rails generated link header takes precedence over yes, it takes precedence, which breaks prefetching. So I had to deal with that. My solution was to remove the link header, but only for SXG responses, and I used Cloudflare Worker for that. So Cloudflare Worker contains if condition. If the request is SXG, then remove this header, right? Otherwise, keep it to have early hints working. There are more constraints on sub-resources. You should use cache control, and it's best to use the higher amount you can. We use 1 year because sub-resources don't change. You can't use cookies, which is very infrequent in static assets. You can't use HSTS-X, but there are ways to work around it, as I told you. There is one requirement which I needed to address. The assets should be loaded from the same domain the main document was loaded, right? So if you have some CDN, I resolved it by rewriting URLs, also using Cloudflare Worker for that. And very important rule, there should be no more than 20 sub-resources. If there are more, they are truncated and not used. And sub-resources are like musketeers. And after experiencing Bartek presentation yesterday, I thought that sub-resources are like, how it's called? Bambinos. Yeah. They care for each other, and they don't like some resource is excluded from the group. So there is this one all or nothing approach. The browser refuses to use already prefetched resources, even if only one failed. So imagine you are at the Google page, you are prefetching 1 megabytes of resources, but one failed, one which weighs, for example, 10 kilobytes, right? And you go to the website, and your browser just discards all those prefetched resources and do it again. That's for privacy reasons too, but I won't delve into details. Yeah, so for example, how it may happen that not all resources were prefetched. Maybe user was quick or has slow connection and prefetching failed because there was not enough time. So the hint is to not serve too much and too heavy sub-resources. Oh, and I used red color for that because it took me a long time to debug. There are the course errors, and I put a question mark there because the course message you see in browser in the developer tools just masks the real issue. The real issue is that the sub-resource is missing from Google cache. And it's normal that some sub-resources are missing, and certain error rate is normal. That's because the storage on cache is not unlimited. The Google has to maintain its cache, so it has to expire old entries and evict even fresh entries if it has not enough space. So you will have to measure it and check what do you have to find a balance, because page completeness. So you can prefetch all the sub-resources on the page, so user clicks and have entire website working. But you risk that many users will have this failed prefetching experience. So it looks like no optimization at all, right? And you can, on the other hand, prefetch only critical sub-resources, which will lead to small error rate. But after visiting the page, the user will have to fetch some additional resources. Yeah, and this is the case. This is the reason I spent so much time preparing this because Google cache is under-documented and sometimes refuses to cache things. So it took me weeks of black box testing because, you know, I saw that, oh, this website, this page is not prefetched because those sub-resources are not prefetched. Everything is correctly generated at my server. Cloudflare seems to work, but for some reason it doesn't work. And I don't know if, yeah. And it's magical because to make it more complex, Cloudflare generates different response for Googlebot than for normal people. So if you try to debug it using curl, you won't see anything suspicious, right? Yeah, there are many things. For example, there are some magic headers you need to include which is not documented anywhere. So now I will go to the demo, this time for real. Okay, so let us open Google results. Let us open Chrome Developer Tools. There is this network, and let's type this query. Okay, I will clear the Okay, so you can see that the result is on the second place, and here you can see the requests. Yeah, and you can see the request is still pending because the network is slow. However, you can see there are some data. Maybe I will filter only SXG traffic. Oh, it is already filtered. Okay. So first, you can see here in this line, you can see that the type of the request is signed exchange. And if you examine it, you will see it is being fetched from Google SXG cache, right? webpkgcache.com. The response contains link header here, which contains the sub-resources. For example, here also served from Google SXG cache. And here you can see there is a font preloaded, right? You can see also, yeah, there is a type. Yeah, there is no hash here, but I will show it to you later. Actually, now. Chrome can decode SXG. So you can see SXG decoded here. Because here is a normal HTTP response. It contains SXG package, which can be previewed here. And you can see some hashing here. And here is the link header for SXG. And you can see it contains real URLs for CSS in this case. And it is duplicated. It's for technical reasons. And you can see here this header integrity. It's a hash, right? So this is the hash I told you that Cloudflare generates automatically. So we can close this and see sub-resources being prefetched. You can see there are more signed exchange requests, such as this CSS. And yes, it's just as before, prefetched from WebPKG cache. And if you inspect SXG, you can see, for example, that cache control is set to 1 year. Yeah, I don't think there are other interesting things. Yeah. So that's it. So SXG is fragile because if you are working in a team and somebody, for example, implements some cookie, it will break SXG, right? Or you use some server-side personalization, etc. So you need tests, and the tests are actually quite easy to write, at least for basic use cases, because you have the SXG requirements clearly documented at Cloudflare and Google pages. So for example, you have a list of prohibited headers to not use or prohibited cache control directives. And how to debug it. I found Chrome DevTools the best tool for debugging. You just have to remember to enable or disable cache because SXG is based on caching. So if you want to test it that way, enable cache, but otherwise disable because you will get stale data. There is a very nice page, simple page, SXG prefetch page, which simulates what occurs on Google results page. So you don't need to wait until your website is at top 3. You can do this on one page. There is SXG validator browser extension, which tells you if given page does not contain any problems, and it also shows you some hints how to improve it. However, I found it unstable. It's working. I use it, but sometimes it gives you false negatives. It tells you that the website does not implement SXG while it implements it. And you can use curl to verify it. Just curl, and there is also a CLI utility, which I haven't used, which is distributed in one of repos related to SXG. But you need to remember that if you use Cloudflare, there is this nice feature called bot fight mode, which prevents bots from accessing your page. So you need to disable it if you want to debug it with curl, because curl is considered a bot. There is also Requestly, which is a browser extension which modifies headers. There are a ton of such tools. And this has this benefit that it's not recognized as a bot. because it's used inside your browser. And there is Google Search Console. So as I told you previously, Cloudflare returns different SXG response to Google. So you can use Google Search Console, I don't know how it is called, inspect URL functionality, which instructs Googlebot to visit your page and extract it, and you can see even HTTP headers. So this way you can debug it. Yeah, and one thing that helps is to, when you check some new thing, want to debug why things don't work, increase assets, your assets version to invalidate all those caches in between, because there are cache at Cloudflare, there is cache at Google, and there is a browser cache, right? So it's easier to change it in one place. And there is measurement. So I don't like measurements because it involves using Excel. And the worst thing about measuring things is that you have some expectations. You implement it, you spend hours implementing something and you expect it to work flawlessly, but it will never work flawlessly. So measuring it gives you contact with reality, which is a sad feeling. I measured two things: LCP, which is easy to measure, and conversion rate, which is important, but not easy. So, what's the naive approach of measuring? Naive approach is that I measure things, how LCP and conversion rate works before deployment, and then I wait some time and compare with results after deployment. But it has many problems. That's because SXG affects only a percentage of your visits, so the results will have low signal to noise ratio, which means you have to collect very large amounts of data to see some patterns there. And yeah, you have to get appropriate amount of traffic, so the results are statistically significant. And a lot of traffic means long data capture. It may take weeks or months. And during this time, you have to restrain from any optimization to not influence the results. And you have also seasonal bias. For example, for my website, the seasonal bias is very large. So the better approach is to compare SXG traffic with normal traffic from the same time interval. So we don't have seasonal bias. But we need a way to distinguish SXG traffic from normal traffic. And we have the mechanism. Cloudflare gives you this special variable set at window. It just, because Cloudflare controls your entire HTML, it can inject some code. And it injects setting this variable to true, is SXG. So you can integrate it with your analytics and performance measurement tools to distinguish those two types of traffic. Yeah. However, there is also a problem with this approach, because SXG users are not normal users, because SXG users saw your website on very top positions, right? So there's a difference if someone visits your page from the third Google page, it means he's very persistent and he has very strong need, right? So those that's why comparing those users is like comparing apples to oranges. So yeah, Windows, this variable is almost useless in my opinion. But there is also a second problem. There is no documented way to check if sub-resources were prefetched correctly. because if you happen to have this coarse error, the user almost won't notice any difference, because he will need to wait for all the sub-resources. And we don't have clear way to do that. So I used this all or nothing, remember Musketeers rule, to detect prefetching. I used canary sub-resource, which maybe, I don't know if it's, maybe I will explain it on my blog in details. There is canary resource which sometimes is loaded, sometimes is not loaded, and I can use JavaScript to tell if this particular sub-resource was loaded or not, right? This is the main idea. So this way I can tell my analytics and performance measurement tools that sub-resources were prefetched correctly. Yeah, and I haven't done this yet, but I have an idea for another sub-resource, poisonous sub-resource, which always fail. And I can inject it on specific pages for A/B tests, right? Yeah, so the modified approach to measurement for LCP, you can compare normal traffic with SXG traffic, but with loaded sub-resources. And for conversion ratio, you compare SXG traffics with intentionally broken sub-resources prefetching to SXG traffics with prefetching working correctly. So probably I spent so much time telling you about difficulties in SXG that you already don't like it, but still I think it's great technology for improving user experience and performance. It is under-documented and contains quirks, and each deployment has to be measured to find the sweet spot between number of sub-resources and error ratio. And that's it. I invite you to subscribe my blog. I will write more about that in upcoming posts. Thanks.
Okay, we have time for one short question. Is it short?
Hey, I'm really impressed by the level of research and debugging you went to optimize SXG. I'm wondering, so you said that after each deployment you have to measure, but do you also have to measure without deployments? Does it break from time to time, especially that it's not documented? Does Google change things over time and you have to fix it somehow?
Okay, thanks for the question. So first thing is that the measurement is not just right after deployment. It takes many days, right? You have to collect data and compare it to, I don't know, you have to collect 1 week of data and see how it performs. So for example, the thing I measure is the error rate. So each time there is a sub-resource problem, I send event to Google Analytics, and then I compare failed with total number of page loads. So I don't know if I answered your question.
If you don't change anything on your website, does it break sometimes?
Okay.
Due to Google?
Actually, I don't know. I don't know because I started measuring this error rate because I was preparing for this talk.
So let us know if it breaks at some point.
Okay.
As Paweł said, to find out you need to subscribe to his blog. All right, thank you very much, Paweł Pokrywka.